So my work focuses on land use, and in New England that primarily means forest loss to development, forest harvesting for commercial timber harvests and other purposes, and land protection through conservation easements and other types of protection. In New England, we have more than 800,000 individual private landowners. So getting to understand how landowners make decisions and what sort of external driver prompts their decision to protect, develop, or harvest is a big part of what we focus on. So in New England, like everywhere around the world, we're experiencing climate change, and we're seeing the impacts of climate change in ecosystems throughout the region. And while those changes are significant, they're really pale in comparison to the changes we're seeing from land use. So for example, you have at once the continued regrowth and recovery from colonial era land use. And we see that that's actually the biggest driver of carbon accrual and species turnover through long-term succession. Overlay that, you have climate change. With that, higher carbon dioxide concentrations, longer growing seasons, increased precipitation, and that's actually enhancing carbon uptake. Overlay on that, the land use. And here you have both the forest loss to development. In Massachusetts, it's around 6,000 acres a year are permanently converted to non-forest. Plus you have between 0.5% in eastern Massachusetts to as much as 2% in western Massachusetts of the forest being subjected to harvest each year, which is putting small gaps in the forest and allowing gap phase succession. So the landscape simulation models produce fine-grained maps at 30-meter resolution where we know individual species, their growth and change over 5-year time steps. And these maps can be aggregated up into products that are easily interpretable by policymakers and stakeholders of all sorts. So for example, the Healthy Soils Initiative, which is a Massachusetts state-funded group that wants to look at how carbon in soils is being affected and may be affected in the future, they became one of our focus groups, and we were able to provide them projections of development and the associated forest carbon loss around the state that then informed best management practices for soil use throughout the state. Similarly, we've worked with Massachusetts Audubon as part of their Losing Ground to show how the potential increase in impervious surfaces would affect runoff and stream flows, which is coupled to other scientific work that we did on the flooding associated with each one of those scenarios, and coupled to a data nugget that we produce that provides curriculums in schools where students in the high school level can analyze the future of their watershed and how different development scenarios might change the flows in their rivers. And so it's been a great example of having this integrative model that leads to new science, new policy, and new educational opportunities. Nice. So as we study the patterns of land protection and the ecological benefits that come from protecting land, we've been really taking a hard look at where lands are protected. We find that households in the highest income quartile have almost twice as much protected land as households in the lowest income quartile. Similarly, communities with the highest proportion of people of color have just 60% as much of nearby protected land. So we've created a screening tool where policymakers and conservationists can look at multiple criteria for land protection, and we include an environmental justice layer so that landscapes can be prioritized on multiple criteria, and they can perhaps make up for this disparity that we see, and we're trying to create tools so that conservationists can look across the full suite of priorities for land protection and make more equitable decisions. One thing that's both daunting and fun about studying the interacting global change drivers is it brings together everybody on the LTER, and we use models and big data and interdisciplinary science to be able to tackle these questions. This is how I like to do science, and this is what Harvard Forest really excels at.